This is a National 5 Unit 3 chemistry video, and this video is going to cover the entire topic of plastics and polymers. So plastics are made from molecules known as polymers, and polymers are long chain molecules formed by joining together smaller molecules called monomers that repeat over and over and over and over again inside your long polymer chain. So each one of those circles represents a monomer that have joined together to form the whole chain, which is called a polymer. The process, or the name of the chemical reaction used to join monomers together in a polymer, is called polymerization. So monomer to polymer is polymerization. So mono means one, poly means many. So the type of polymerization that we cover in National 5 is known as addition polymerization. And that word addition, when it comes to reactions, usually means that you're starting with an alkene, and that is exactly what we have in addition polymerization. So the monomers from an addition polymerization reaction all are alkenes. They all have a carbon-to-carbon double bond in them. Remember, that means it is unsaturated. So monomers are always unsaturated. The simplest monomer that can be used is ethene, C2H4, as shown in the diagram. When ethene monomers join together to form a polymer, what we call it is polyethene, sometimes shortened to polythene. But polyethene. So how do we think that they join together? Well, in an addition reaction, remember the double bond breaks. Now, instead of a brand new substance adding on, what we're doing is just adding together all of the monomers. So what's happening in each one of these reactions is that the double bond is breaking in each one of these molecules, and a new bond forms between the carbons. And we always show additional bonds like that forming in the end. So we can see this was our first monomer, then our second monomer, our third monomer, and our fourth monomer all together. We need to have these bonds on either side to show that the chain can continue. Okay, so we don't leave it with just the carbon atom. We need to have the bond on either end of our polymer to show that it's actually a much, much longer chain that can form. But in each case, you break the double bond and then you form bonds to the neighboring monomer. So how do we show this happening? Well, the chemical is added which breaks the double bond between the two carbon atoms to make a very reactive unit known as our repeating unit, or our monomer. So it's always important to draw bonds to the sides of the repeating unit if you're asked to draw it. So a question can be, draw three monomers joined together, or show the repeating unit. If they're asking for the repeating unit, and even when they're asking for three monomers joined together, you have to make sure that you always have these bonds coming out the ends of your chain or your repeating unit to show that it repeats. Now, once you've got your reactive units, they join end to end to make a bigger molecule or a polymer. So for example, if we have two repeating units, it will look like that. And it repeats over and over and over and over and over again. When we have a polymer, it's often very, very difficult to actually know how many carbons are in the final chain of the polymer. So the process is called an addition polymerization because the monomer units are added together to give one product, and it's a series of reactions in which you're repeatedly breaking the double bond and forming bonds to the next monomer, to the next monomer, to the next monomer, to build and increase the length of your polymer chain. Now you can shorten the polymer. For example, that very long chain of polyethylene can be reduced to this format where we have the repeating unit with brackets around it. Again, you need to make sure that these bonds are drawn on either side and that they stick out beyond the bracket. And then we just use n, which n means any number, which means that that chain length can be n equals 100, n equals 1,000,000, n equals 1,000,000,000, and it's still a polymer. However, in SQA exams, they usually do ask you to draw 3 monomers connected, and if they do ask for 3 monomers connected, you cannot shorten the formula to 1 monomer with n equals to 3. They want you to show all 3 connected. So sometimes you'll be given a monomer that does not just have 2 carbons in it and other groups sticking off the end. Sometimes you'll be given a monomer that has 3 or maybe 4 carbons in it. What you have to do is look at identifying where the double bond is and redrawing the monomer they give you in a format which has just the 2 carbons in the double bond in the middle and then everything else sticking up and down around it. So for example, propane has this CH3 group, which we can draw pointing up here. Then when we can draw our 3 monomers together, like that, and connect them as so. Again, remembering in our final monomer, final polymer, have these bonds sticking out either end to show that it can continue. Now here's a question directly from a past paper, and it says polystyrene is made from styrene, and it's drawn it out. So it's asking you to draw a section of polystyrene showing 3 monomer units joined together. So the first thing I would do is draw out the first monomer. Remember, the double bond is broken. So we've got that, and remember, we need our bonds either side. Now let's just continue and draw the second one. And the third one. Like that. So it's relatively straightforward. It actually doesn't matter if you draw that C6H5 on the left-hand side or the right-hand side carbon, as long as there's always a gap. Carbon, 2 CHs, then carbon with that. Carbon with 2 CHs, carbon with that. And it's typically 3 monomers joined together. Remember to have your bonds on either end. So an alternative way that the SQA can ask the question is to give you a chain and ask you to identify the monomer. Now the best way to do this is to look for a unit that repeats itself within the structure before even looking at any of the options. So I can see that every other carbon has a CH3 coming off of it. So that would mean we've got a repeating unit here, like that. So now all I need to do is look at this one thing and look at which one of the options best represents that. Now remember, it is a monomer, it is not the repeating unit, and monomer always is unsaturated, which equals having a carbon-carbon double bond. So we can immediately eliminate these bottom 2. Then, if we look, well, This one here has one CH3 group coming off the carbon. This one here has two. Our repeating unit here only has one. So our answer is going to be A. A harder version of that question, it talks about a copolymer. And a copolymer means that there were two different monomers that then occur in a repeating pattern one after the other in a polymer. So in this one, it says two different monomers polymerize. Part of the copolymer has been shown and there have been three monomer units. And it's given below, and it says one of the monomer units used is propene. Identify the other monomer, and it gives you four options. So the most important thing to do is propene. What does propene look like? Well, propene has three carbons in a chain, and it's propene, so it's going to have two carbons like that. So it's best to draw propene as something like this, CH3, and then an H, an H, and an H like that. Okay, so we can see something that looks like that right in the middle here. So that is our propane. So then we've got two other things, and they both look the same. They have a CH3, a CH3. So that's a repeating unit. So if I turn that into a monomer, all I do is make it a double bond in the middle. So that's what it looks like there. And we can see that that's what we have in position number 1 and position number 3. If I could draw 3 properly, that would be good. But then all we need to do is name what this monomer would be. Well, it's got 1, 2, 3, 4 carbons in it, so it's going to be a butene. So we can eliminate our 2 pentanes here. The double bond is between carbon number 2 and carbon number 3. So this is butene. So that's our other monomer. So that is a really difficult question, so I thought that was important for me to give an example of. Now the final thing we need to be able to do is name polymers, and this is very easy because all we do is put poly in front of the name of the monomer. So ethene becomes polyethene. So obviously we've already done polyethene, but vinyl chloride, all we do, poly, vinyl chloride, or PVC as it's more commonly known. Propene, if that's the monomer, well, polypropene is the name of the polymer. And styrene, well, the polymer is polystyrene. So naming polymers is very easy. You just add poly in front of the name of the monomer. So that has been us gone over all of plastics and polymers. So we covered what a polymer and what a monomer was. We looked at drawing polymers based on monomers. We looked at identifying monomers based on a chain. And then we finalized it by understanding how to name polymers. We also learned that the name of the reaction used to form a polymer from a monomer is called an addition polymerization reaction. So that has been the plastics part of Unit 3.